You ever stop and wonder how a chatbot or even your phone's translator actually understands what you're saying? I mean, think about it. Computers only speak the language of numbers, right? They don't get poetry or sarcasm. So let's dive into this incredible journey and figure out how they go from our words to their worlds.
The whole mystery really comes down to this one question. How can a machine, which is all about pure logic and code, possibly wrap its head around something as messy and nuanced as human language?
Okay, look at these two sentences. For you and me, the meaning is crystal clear. But for a computer, the word bank is just, well, it's just 4 letters, B-A-N-K. It has zero meaning at first. So how on earth does it learn the difference between a riverbank and a money bank?
Well, the first huge leap forward came from an idea that sounds almost too simple. If computers only get numbers, well, why don't we just turn our words into numbers?
Think of it like this. Every single word you can think of gets its own unique set of coordinates. It's like giving each word a specific address in this enormous multidimensional map. That's the very first step in translating our language into theirs.
Now, this whole technique has an official name. It's called word embedding. But here's the thing. It's not just about giving words random addresses. The real magic, the genius of it all, is how these addresses are chosen. They're designed to capture meaning itself.
So what's the secret sauce? The AI learns by reading, and I mean reading. It goes through billions of sentences from books, articles, the entire internet, and it starts to notice patterns. It sees that words like king and queen or puppy and dog tend to show up in very similar sentences. So what does it do? It places their coordinates right next to each other on its giant map.
And this is where things get really, really weird, in the best way possible. When you map out words based on how they relate to each other, something incredible starts to happen. Language. It actually starts to follow the rules of math.
Yeah, you heard that right. Because all these relationships are now just numbers, they're vectors, we can start doing arithmetic with them. We can literally add and subtract concepts to find new relationships.
This leads us to the most famous, the most mind-blowing example of this word algebra. Get this. You take the coordinate for king, then you mathematically subtract the idea of man, and then you add the idea of woman. The final coordinate that the math spits out is incredibly close to one specific word, queen. It's amazing. It shows that the model figured out these complex ideas of gender and royalty all on its own, just by reading text.
Now, for a long time, this was absolutely revolutionary. But this beautiful mathematical map of words, it had a big problem, a hidden flaw. It just couldn't handle how messy real everyday language can be.
Which, brings us right back to where we started. Words aren't set in stone. Their meaning can totally change depending on the other words around them. So what happens when a single word can mean 2, 3, or even 4 completely different things?
So in this original system, our friend the word bank gets just one address, one single point on the map. And that point is basically an average of all its meanings. So it's kind of financial and it's kind of geographical, but it can never be purely one or the other. It has no sense of context.
Solving this context problem wasn't just a small tweak. It took a whole new way of thinking, a development so big that it kicked off the modern AI revolution that we are all living through right now.
The answer came in 2017 from a game-changing research paper called Attention is All You Need. And honestly, that title wasn't an exaggeration. It really did change everything.
This paper introduced a brand new architecture for AI models, and you've definitely heard of its descendants, like ChatGPT. This new architecture is called the transformer.
So the transformer has a superpower, and it's called self-attention. Instead of giving every word one fixed address on a map, it lets the model look at all the other words in the sentence and decide for itself which ones are the most important for figuring out the meaning, right here, right now.
So how does this attention thing actually work? Okay, a simple way to think about it is this. The word we're analyzing, let's say bank, it sends out a question, a query basically asking, hey guys, what do I mean in this sentence? All the other words in the sentence act as keys, like they're raising their hands, offering to be a clue. The model then looks at all these clues and scores how relevant each one is. Then it uses that score to pull in the meaning, or the value, of the most important words. So back to our original sentence. When the model gets to the word bank, its attention mechanism immediately sees the word river.
It gives a huge important score to river and a tiny little score to words like she and sat. It basically says, aha, river is the key clue here, and instantly it understands we're talking about the side of a river. Problem solved.
And this one breakthrough, this ability to pay attention to context, is the engine behind almost all the advanced AI you use every day. We're talking chatbots that can actually hold a conversation, translators that work instantly, and even AI that can write poetry or its own computer code. It's all powered by attention.
So we've come all this way. From giving words static addresses on a map to building dynamic models that can actually understand context. And that leaves us with one last, really fascinating question to think about. If machines have now conquered context, what's the next great challenge? To truly, deeply understand human language.